So in this next video, in going over algebraic proofs in A level, we're now going to look into the first type of algebraic proof through an exam style question. So what I have here are three exam questions, one from each exam board, AQA, Edexcel, and OCR. And prior to this video, I have already talked about the different types of proofs that you'll cover in A level, but also extending from GCSE. And also having a reminder on the different types of numbers that are used in this topic, because we need to understand these words or phrases, which we'll see in these questions, in order to have a visual idea of what to expect. So let's go into this. And this first question is from an AQA paper, and we are going to be covering general proofs. So general proofs, you can see that you just have a statement, but you just have to show that it gets to the outcome that they are asking for. So we are told, given that n is a positive integer, and as I said, these phrases, for example, we need to know what an integer means when it's positive. So again, in the previous video, I talked about this. Now we want to express, so we have an algebraic fraction. So this is something we've done in GCSE, but we use it again in A level. So this algebraic fraction, and what we want to do is turn it into a single fraction, but the condition is that there's no surds. So let's do this. So I'm going to write it. It's 3 plus 7 over 3 plus 5 root n minus 7 over 5 root n minus 3. So yeah. So what I'm going to do is I can take away these fractions, just as we take away fractions as normal. It's just that our denominators look much more harder than usual. So what I'm going to do is, because I want the same denominator, I can just basically just multiply these two terms. This is going to be my new denominator. So that means on top, if I multiply 7 over 3 plus 5 root n by both of these brackets, I'm going to be left with on top 5 root n minus 3 times 7. So I'm going to have 7 bracket 5 root n minus 3. And what I'm going to do, I'm going to basically connect it to each other because I'm going to have the same denominator. So I'm going to have 3 plus 5 root n bracket 5 root n minus 3. So that's why you can see I times the 7, the first one, by 5 root n minus 3, because it already has 3 plus 5 root n. And then I'm going to minus it, so the second 7, it now has 5 root n minus 3. So if I was to multiply this by this whole denominator put together, I'm going to have the 3 plus 5 root n, which it doesn't have. So I'm going to put 3 plus 5 root n. Now this is my single fraction. So this is my single fraction. So I'll write in short Sn. So now the next step is we want to basically show that it doesn't have any surds. So clearly I know in my denominator I have a difference of 2 squares and my surds are going to cancel out. So let's now expand and simplify and get this into a single fraction without a surd. So on top I'm going to have 35 root n minus 21, and then minus 7 times 3, so that's going to give me minus 21, and I'm going to have minus 35 root n. And then underneath in my denominator, difference of 2 squares, so I'm going to have 25n minus 9. So I'm just basically splitting it up. So now that I have my single fraction, now I want to simplify things. So from here, I'm going to now take my 35 root n can cancel out, so I'm going to have minus 42 on top divided by 25n minus 9. And then I can have my minus sign out front. So 25n minus 9. And that is it. And now part B is saying that, hence deduce that what we've worked out is a rational number for all positive integers values of n. So again, we need to know what a positive integer. So this is basically numbers that are whole numbers, and it's going to start from 0, 1, 2, all the way up to infinity. So now we want to show that for any number, it's going to basically, we can get a rational number. So again, a rational number, we need to know what it is. A rational number is basically when you have a fraction, you can have a fraction or a decimal or such, but If it's a fraction, you're going to have an integer on top and below. So as a rational, you can't have surds in the denominator, and so forth. So let's now test this. So let's use n is 0. Because if this is the smallest possible integer that's positive, then that means for any other possible integer, it's going to work. So if n is 0, I'm going to then have minus 42 on top, and then 25 times 0 is 0, so minus 9. Minus divided by minus is going to give me a positive, so I'm going to have 42 over 9. Now, this is a rational number because I have an integer, a whole integer on top and a whole integer underneath. And it doesn't matter even if I have negatives. So if I was to then have n is 1, so I'm going to have 42 minus 42, then underneath I'm going to have 25 times 1, 25 minus 9 is 16. So I have minus 42 over 16. This is still rational. It doesn't matter whether it's a negative or positive, as long as your fractions, it has a integer on top and underneath. So that's that. So this is one type. This is from my AQA. Now the next one we have from an Edexcel paper. So this one says prove using algebra that n plus 1 cubed minus n cubed is odd for all n is a set of large n. So again, in the previous video, I talk about how not only do we need to know the words, but also to have their symbols. So this n, it stands for natural numbers. And we're given a statement, so we just have to prove it generally that this is odd for all natural numbers. So what we can do is that we can expand this out. So of course you can write out all three brackets. You could use binomial expansion, but I would just like to expand it all out. So if I was to expand it with double brackets first, so I'm going to get n squared plus 2n plus 1, and then times this by n plus 1, and then I have my minus n cubed, which will come later. So let's just continue to simplify this all out. So I'm going to have n cubed plus n squared plus 2n squared plus 2n, and then plus n plus 1, and I'm going to have my minus n cubed. Now I can see my minus n cubed can cancel. So now I'm left with my n squared, my n's, and the 1 at the end. So I'm going to have 3n squared plus 3n plus 1. So this is now my final expression. But now I need to prove that this is odd for all numbers of n that are natural. So what I'm going to do is I want to write this in a neater form. So I can factorize out the two terms. I can have 3n squared plus n plus 1. So now if I want to prove this, this is odd for all numbers of n that are natural. If I just quickly just rewrite my natural numbers, so natural numbers are numbers that are from 1 is a 1 going all the way to 3, all the way up to positive infinity. So any whole number is a natural number. Now, if I want to show this is odd, I know for sure that whenever you're using algebraic proof, if you have a plus 1 or you plus any odd number, you're going to get an odd number. Because we know that an even plus an odd is going to give you an odd. And also an odd plus an odd is going to give you an odd. So the fact we have an odd number at the end, that's good. But we need to show that for any natural number, we want to get such, even or odd, so we can add to 1 to give us a odd number. So what we want to do here is basically, let's look more into n squared plus n. Now, if we take any number and you square it, whether it's even or odd, because n can be an even or odd number as an integer, because we know 1 is odd, 2 is even. So the only possible types of numbers you can have is an even number or odd number. Now, when you square an even number or an odd number, you're always going to get an even number or an odd number. So for example, 7 squared is 49. You can have 4 squared is 12. So these are the possible solutions you get when you square it. But now, because it's n squared plus n, if you have an even number and you square it, that's going to give you an even number. But then if you add n again, which is the even number, so even plus an even is going to give you an even number. So as we said, if you have 4 squared plus 4, that's going to give you 16 plus 4, which is 20. Now, if I have an odd number, so if I have an odd plus an odd, let's see what happens. So if I was to do 7 squared plus 7. Now, 7 squared is 49 plus 7. That will give me 56, which is even. So we can see whenever you square any number that is even or odd, and then you add it to the number that you have as n, you're going to end up having an even number. So what I can say now is 3 bracket n squared plus n plus 1. I'm always going to end up having an even number inside of my bracket. But now, because 3 is odd, so I know an odd times an even is going to give me an even. So what I can do is basically write 3 and any even number that I have, which we now know is going to give me an even number. So I'll put 3 plus n squared plus n. If I add 1, so if I add, or in this case, because I'm adding 1, so I know for sure the next number that comes out an even number has to be odd. So therefore, I prove that n is going to be, for all set of natural numbers, is always odd. And that's essentially it. And you can even try this. So any number you can think of. So if you have 5 squared plus n, that's going to give you 25 plus 30. Now 30 is even. Even times an odd is going to give you an even number. So 3 times 30 is 90. When you add 1, because the number that comes after an even number is odd. So you're always going to get an odd number. Now, moving on to the next one. So this question now is a OCR question. And what we have is the following. So it says a student wishes to prove that for all positive integers, so you can see now, our positive integers, by now we should know what that is. So it says a and b, and then the expression. So it says a squared minus 4b is not equal to 2. So prove that a squared minus 4b is equal to 2. So if this is the case that a squared minus 4b is 2, then a is even. So we want to prove that a is even given this statement. So what we could do is I'm going to write this, a squared minus b is equal to 2. Now we want to show that a is going to be even. So what we could do is let's make a squared a subject. And I'll explain why that's the case. So a squared is going to be 2 plus 4b. Now, if I know that b is a positive integer, so any number that is a positive integer, of course, 4 times an even number is going to give me an even number. So now if I have an even plus an even, because remember b is a positive integer, so it has to be a positive number that is greater than 0. So it could be 2, it could be 4, etc. So that means if I know that my a squared is going to be even, because an even plus any number that is b is positive is going to be even, therefore a squared is going to be even. Now, with this being said, as you saw in the previous question, if I know n is odd, and then n squared is going to be odd as well, because we looked into square numbers. For example, 5 is an odd number. Square 5, you get 25. 3 is odd. 3 squared is 9. 5 squared is 25. 7 squared is 49. 9 squared is 81. And so forth. 11 squared, 121. So if you have an odd number and you square it, you're going to get an odd number. So that means if my a squared is an even number, so we can think of some square numbers that are even. So let's think of square numbers that are even. So you can have 16, you can have 36, you can have 64, you can have 100. Yeah, so these are basic ones. So all of these square numbers are even. If I was to square it to show that A must be even, of course, if I was to square root these numbers, I will get 4, I will get 6, I will get 8, I will get 10, and so forth. So that means if my A squared is even, then my A is going to be even. So we've proven that's the case. So now let's look into this final part, 7b. So now it says, hence or otherwise, prove that for all positive integers a and b, that a squared minus 4b is not equal to 2. So because it's saying hence, let's just use what we worked out and continue. So we want to prove that for all positive integers, so a and b, these are positive integers, that a squared minus 4b is not equal to 2. So a positive integer is going to be even. It has to be even. Now we can write any even number as 2n because anything multiplied by 2 is going to give you an even number, whether n is odd or even. So if I can now express all my positive integers as 2n, I'm going to substitute this 2n into my equation of a and b as a positive integer. So 2n is a positive integer for a and b. So I'm going to sub 2n into this equation. So I'm now going to have, let me just move this here. So yeah. So now I'm going to now basically sub in 2n squared minus 4 bracket 2n. And I want to show that it's not going to equal to 2. So now what I have is I'm going to have 4n squared minus 8n. And that is equal to 2. Now what I could do is I could factorize it out. So I'm going to have 4n. Well, I can have just 4 bracket n squared minus 2n. And that is equal to 2. Now, because we said a and b, which we have written as 2n, so this is going to be a positive integer. So any number that is a positive integer is going to be a multiple of 4. And it doesn't matter whether it's negative or positive. Because if I was to get the smallest number, I can then have 4 times 0, and that is 0. I can have 4 times 1, and that is 4. If I was to have 4 times negative 1, I'm going to have negative 4. So it would never equal to 2 because this is a multiple of 4. C, it will never equal to 2. Also as well, if I was to take A just to be 2n, so I can then have 2n squared minus 4b equals 2. Let's say b is a positive integer, but I want to express n, I want to express a as just the only positive integer. So I know, okay, 2n, I'm going to have 4n squared minus 4b is equal to 2. If I was to factorize it out by 4, I would have n squared minus b is equal to, not equal to 2. Again, I can see that anything as a multiple of 4 would not give me 2, whether it's negative or positive. So therefore, it will never equal to 2. Because now if I was to now use positive integers, so let's say n is 2. Let's say n is 2, so 2 times 2 is 4. 4 is a positive integer, which is a, because my 2n is 4, which is equal to a. Let's say b is 6. So if I know I have my 2n squared, which is 4, so I want to have my 4 squared minus, so 4 times 6, it's going to give me 16 minus 24. That is minus 8. It's not equal to minus 2. And these are the smallest numbers. So let's say even if A was 2, B was 2. So I only just basically used it when my 2n is 2, which is A. But now let's use the case where both A and B are even the same numbers. So if A and B are exactly the same numbers, I could then, in any of these equations, I would see that I am going to get a number that is not equal to 2. Because even if I was to sub in 2 squared, which is 4, and then minus 4 times 2, this is going to give me 4 minus 8, which is minus 4. So yeah, and that is not equal to minus 2. So therefore, I've proven that for all positive integers of a and b, a squared minus 4b is not going to equal to 2. It can't. Because you can see I'm going to have a multiple of 4, and in my multiples of 4, I can't have a 2. And the fact that my numbers, a and b, have to be integers, I will never get a number as 2 within my multiples of 4. If it was allowing us to have fractions, then yeah, we could have 2. So yeah, so these are the questions, and you can see across the different exam boards, OCR, NXL, and AQA, you can see how we need to know the words for different types of numbers. We need to know the symbols, and we basically need to use our logic of numbers, understand our numbers in a lot more depth, understand the connection with odd numbers, even numbers when you're multiplying them, when you're squaring them, when you're adding them, if it's going to give you an odd or even, and that will allow you to know if you're on the right track to making your proof work. So I'll leave it here. And if you want any more questions like this, where I go over them in more detail, I do have a online portal where I have many questions in different styles for all exam boards. And I am also offering a free group sessions in this month only during the holidays. So that this is for students that want to keep up with their learning. That's something that I will be offering. So if you're interested, you can reach out to me or you can comment in the video and you would receive a link for more details.